In today's presentation, it's really intended to bring management level folks up to speed with point clouds. It assumes that you maybe don't have a lot of background in laser scanning and reality capture and kind of the basics that you'll need to know to oversee a project. The idea here is not to fully educate people on laser scanning. If you're a user of laser scanning, we have a lot of other webinars we've done in the past that go into more detail of how you actually implement point clouds on your project. The topics today will be an introduction to reality capture and what to expect from scanning. And we'll actually end up close out with going into some details on how to estimate what the cost of scanning might be on your project. So a brief introduction to reality capture. Reality capture is sort of become a word that encompasses what's still today primarily laser scanning, but also includes things like photogrammetry, where we're using 2D photographs to generate 3D models. And we're doing that with drones and as well as still camera images. And as the future kind of unfolds, it's not as simple as saying just laser scanning. There's a lot of different ways that we're going to capture and digitize the real world and a lot of different devices. A core thing, in this presentation we're going to focus a lot more on the laser scanning than on the photogrammetry or other capture methods. And with that, one of the things you need to understand is there's a difference between color and black and white scans on a project. One of the biggest differences is in the time it takes to capture data, and this can have an effect on projects that have compressed timelines or limited access windows to the site. So we have a lot of different equipment that we use, and in general there's always trade-offs to this stuff. There is no perfect equipment. So with the traditional kind of laser scanners that we use, these are going to be the small mobile units. You're going to be getting about plus or minus a 1/4 inch accuracy out of the scan data. And I want to point out, these are not, if you look up the specs that the companies put out on these machines, these are not going to match. These are real world, what you could really expect to get out of these machines. So on the traditional scanning, the capture speed is going to be fast. It's going to have about a 50-foot practical range. Again, like I said, these machines claim ranges substantially more than that, and there are purposes where they're adequate for these extended ranges. But in a general, the smaller machines are going to be good to about 50 feet. We switch over to aerial drones. This is done using 2D photos. Important to understand the difference between laser capture on drones, which is not really a production technology, and what is being done today. What is being done today is 2D photo capture that then computers convert to 3D models. And because of that workflow, the data you're going to get is going to be plus minus a couple inches, but we're going to cover massive areas in a day, and we're going to have very, very long range on them. Then we get to kind of the more survey grade laser scanners. These are the heavier, less portable units. They're going to hold about the same accuracy or even a little better, but they're going to give you much better range, 250 feet. So if you have a site where you need the longer range, maybe a stadium, things like that, or building high-rise building facades, these are the appropriate machines for that type of work. Then you get into the new generation of stuff, which are mobile scanning units. These began as car-mounted mobile mappers or train-mounted mobile mappers. They've now begun the journey to being inside units. These are very, very fast. Accuracy is complex on these units, but needless to say, it's not the same as traditional scanners. Several inches would probably be generous in some cases, but in other cases it can be adequate. Again, ultra fast and a range of about 50 or so feet. Expect kind of the project to unfold in sort of 4 different phases. Again, this is specifically for scanning. We're going to start with a plan. We're going to go on site and complete the scan. The scan will have to get registered, that we're going to talk about in just a minute, and then outputs have to be generated. So important to not confuse the completion of on-site scanning with final data delivery in a usable format, there's still quite a bit of time involved after the on-site work is completed. So some quick notes about on-site scanning. It's going to take 5 to 15 minutes to do each scan. Expect 4 to 5 scans roughly per 1,000 square feet. These numbers are based on historic averages of what we actually see in real data that's come in. Of course, there's projects that come in under this and over this, but these cover about 90% of the projects we do. It's best to scan when no one is at the site, especially if you want high quality color capture. If you're not worried about color capture, you can certainly do it while the site is active. And depending on the size of the project, you're going to need targets. And again, this would lean more towards the inactive site. If people are moving our targets around, that's a big problem. And then if you need multiple site trips, you're going to need to install permanent targets so that data can be lined up between sites and repeated. So I mentioned we're going to talk a little bit about registration. Registration is the act of stitching the individual scans together. And in general, this is also where some quality problems can come into the process. The scanners themselves are very simple to use nowadays. They collect very good data with very limited training. However, once you get to registration, this is where a lot of problems can come up. Some of those can be caused by poor scanning technique, but there's also other issues that can arise. Basically, what we're doing in this step is we're taking, 10 to 1,000 individual scans and connecting them all together into one point cloud so that we can work on the data of an entire site. An important part of this step is going to be aligning the point cloud data. We see this step get messed up an awful lot. And in general, this is when the scanner is run the first time, that will establish the alignment. And this is never going to match your site alignment. So if you have existing CAD files, we need to line it up to that. If you don't have any existing CAD files, you're going to need to line it up to some logical coordinate system. No one wants to work on data that's crooked, that has an origin point out in space. You need reasonable aligned data to execute your project, and this needs to be done at the registration step, not manually aligned within CAD. That leads to very poor final results. So we move in. Once the data is registered and aligned, we're essentially done with processing the point cloud. Now we're moving on to the different output formats. And those are going to really come in 3 different flavors. The point cloud itself, so more sophisticated users may only want the point cloud. If you have a team that's been using this data for a while, that's all they're really going to want. Newer teams, I would recommend always would start with CAD files that are developed. So the CAD file is developed from the point cloud. And then you have report data, which can take a number of different deviation reports, different analysis that can be done based on the point cloud. These could be collision reports, interference reports. A lot of different outputs can be done that fall under the report data. The exports of the point cloud should be done in kind of manageable steps for your team. Using that data effectively is going to rely on this step being executed well so that you're not having gigantic point clouds deployed to you. You have a manageable, workable data set. You can have obviously CAD or BIM data created. If you're looking for something beyond CAD and more into the BIM and the smart model, you need to know that ahead of time before the people go out to scan so that potentially additional information can be collected. So I touched on a little bit kind of the difference between a scan and a model. I just want to talk about that a little more in detail as we see a lot of non-technical folks get caught up on this. A scan is just a series of dots. It's not classified. Objects don't know what they are. A wall doesn't know it's a wall. A door doesn't know it's a door. It's just dots. And they can look really good. Like the picture we're looking at right now is a scan. It is a colored scan of a NASA laboratory. And the thing is, this does not work for most projects. Most projects, you're going to need to develop some or all of the point cloud into CAD so that it can be worked on by your designers, your engineers to produce bid documents or construction documents down the way. Some extremely sophisticated customers can use the scan intermixed with some CAD data or BIM data, but in general you're going to be doing BIM or CAD derivative work from the scan, and this is a very manual process. There are tools out there that are semi-automated, but there's nothing out there that will simply convert a CAD or a scan data into a Revit model or AutoCAD model. It's always going to involve a fair amount of manual labor to trace over top of the clouds and get workable quality CAD deliverables out. So here is the same thing converted to a CAD model. Just to give you an idea, it's a little hard to tell from these pictures, but in here objects know what they are. Pipe knows their pipe, elbows know their elbows. This is a workable CAD model that derivative work can be done on. A concern with outputs, and as you kind of manage a project that involves point cloud data, even very well organized point cloud data sets that have been filtered and had everything done right to them are still very, very large. And it's important to understand they're larger than probably any other data your company has ever seen. So if you have not worked with point clouds before, you need to take some steps to prepare for point clouds to be coming into your office environment. You likely don't have enough capacity on your file servers to hold the data. There's different workflows you need to make sure you get right to keep your project moving forward. Our average point cloud project is going to be 45 gigabytes of data. Our largest point cloud projects will be in the terabyte range or larger. Now, as I tell people, I worked at an architectural firm and started up scanning over there, and in my first year of scanning with them, we generated more data than they had in their entire 30-year history up to that point. So scanning is a totally different level of data, and it's very manageable today. Hardware, software, everything is much better, but you should still plan for it and be ready for the data to come in so that it doesn't cause a problem on your project. So outputs. This is so much easier than this used to be. In general, for 95-98% of the projects we do now, we produce structured RCS files, which is an Autodesk format, and it works in every product that Autodesk makes. If you happen to be using MicroStation or some other products, there are different formats that need to be generated. But in general, every single CAD platform, design, engineering platform out there now contains native support for point clouds. You do not need to buy any special software. There's always software out there that will make working with the point clouds easier and better, but you can, in your current environment, work with point clouds without any additional software needed. So we're going to move to the next section here of kind of what to expect from scanning, and kind of getting expectations in line. Maybe this is your first project where you're going to implement scanning. Maybe it's the biggest project you've ever implemented scanning on, and you want to have an idea of what this is going to take. So quickly, some examples of on-site work. How long do we need to be at a site for? And I said this becomes very important if you want to get those high-quality color images, because the site really needs to be pretty inactive to get that. If you can scan your site while it's running, this becomes less of an issue. But real quick, kind of a couple examples, right? So a 25,000 square foot job, these are pretty easy to do. It's going to be one person with just a scanner. This can be carried on a plane as a carry-on bag. Pretty simple. They're going to be on site for 12 to 15 hours would be a very safe number. It's probably going to be less than that depending on the complexity of the site. They'll be in and out in one day. Very easy to do. You get into the larger sites, an example of a 1 million square foot site. We're going to be bringing in a lot of different equipment, survey equipment, targets, cases of targets, multiple scanners. We're going to be looking for a place that we can lock up our equipment overnight. A lot more planning that needs to happen in these larger jobs. And then, of course, jobs in between. So moving into schedule. So when we're looking at kind of how long the different stages are going to take, I think one of the interesting things and metrics that we track is our scan run times. And we have data going back over 10 years on this now. And we know, with every job, the average scan time that it takes. So this is a chart showing the average minutes per scan. And I think what's really important, if you look at the upper chart, is that compared to the blue line compared to the gold line, is that the times have stabilized. And so we get very, very predictable results. So if someone says they're going to be on site for a week, they're going to be on site for a week. They should never, tell you they're going to be on site for a week and have to extend it for 2 weeks. That just doesn't really need to happen anymore. And the same sort of transformation that occurred on the hardware side with the scanning has also occurred on the software side, where the processing minutes per scan used to be all over the map, and now it's very stable and very predictable. So here's an example. These are real examples based on some smaller projects that we've done. This is just a 14,000 square foot boiler room at a hospital in Connecticut. The scanning, with travel is 2 days. So the scan was 1 day, travel, a day on either end of that. And then one thing you'll notice here is that the model took a very long time in comparison to the scan. So, we did the scan, did the registration, got all the exports done, and transferred data around in about a week. And then the modeling took almost 3 weeks to get completed. That's pretty normal. And I can tell you from experience, almost no matter how small the project is, getting a Revit model done in anything under 2 weeks is extremely difficult, just because of the ramp-up time and getting people assigned and making sure that the model gets checked and that there's review meetings. It's very, very difficult, no matter the size of the job, to get the model done in less than 2 weeks. And then we move to a much larger scanning project. So here we're at 1.3 million square feet. And the one thing you'll notice is that this has not scaled linearly in time at all. So what we are able to do on the larger projects is assign more people to the project. Right? Very, very difficult on a small project to assign, let's say, 25 Revit modelers to that project. It's unrealistic. When we get to these big ones, it's easy to assign many, many people to coordinate on the project together, both in scanners and in modeling. So in this project, we actually ran 6 people, 3 times 2 shifts to scan the factory, and in this case, it was done while the factory was in operation. Still takes, a long time to deliver 3D models that are of this scale. Quick kind of overview of some budget numbers for costs. Right, this is important information if you're maybe bidding a project or getting the project, looking to consider maybe whether scanning makes sense versus traditional field checking. The one thing to consider there is obviously what we're doing with scanning is not really equivalent to traditional field checking. Definitely much more high-end data. So how much scanning cost is really going to be a factor of what type of building and how large the building is. So, warehouses that are mostly open and empty are incredibly fast and easy for us to do. Historic buildings don't always cost a lot more to scan, but they cost substantially more to model if we're doing all the historic detailing into the model. Then as we move into, some other things like demoed office space versus occupied office space. Demoed office space is really pretty close to warehouse space. Occupied is a little more challenging to do. And a quick kind of look at the graph of kind of how the prices really move up as we get into the historic work and even occupied offices. This, of course, assumes we're doing furniture and things like that in the office space. And then the modeling as well. You can see the price per square foot tends to be, definitely the most for historic, although as you get into very large historic buildings, maybe a large museum, the cost can come down a little bit because some of the investment in Revit families and things happens and helps kind of keep that under control.